Hello, this is the Node.js API working group for July 14th, I believe it is today. We're still waiting for some more attendees to join, but wanted to start the broadcast so anybody who's watching live knows that we are going to be starting soon. So far we have Arun, Ian, Samson, and myself, and we'll see who else we get. So I think we'll wait for at least a few more minutes. Maybe at 10 after we'll start either way.
Sounds good.
Okay, 2 more minutes and then we'll get started. I think we had more people who indicated they could make it, but I think we should proceed anyway, and at least they can watch the recording afterwards if they couldn't make the time.
Good.
Hello.
Oh, hi Ali, how you doing?
Hey, Ali.
I'm just going to repaste the link to the minutes into the chat so you can add yourself. And if you want to also add the stand-up section, good. So I think we're going to get started. It's 10 after. What we have on the agenda for today is a quick stand-up of what we've been working on since the last meeting, a quick review of the actions from last meeting, and then finally the main thing we want to spend the bulk of the time on is an update on the API, on the work for the API stable module by Ian, Samson, and myself. Are there any other things that people want to add on to the agenda as well?
Nope.
Okay.
We could. Do you want to talk about some sort of milestone planning?
Sure. Let's put that on the agenda at the sort of after the update.
Okay.
I think that may make sense after we've gone through where we're at.
Yeah.
Add that in. Okay. Okay. So in terms of quick stand-up, so myself, I've been working on getting with the rest of with Samson and Ian to get the NAN examples running, which we do have running now. Refactored the API that we're working on to remove C++ elements. And we might want to talk a little bit about that later. Through some of the work, Ian, through the work, I think most of us have sort of come down to that the core API needs to be C as opposed to C++. And I think Ian even came up and found a document where, I think it was Oracle had done a fairly significant investigation, and that was their conclusion as well. Not to say that there can't be C++ wrappers and stuff to make it easier to use but the core API itself, really seems to always revert back to something in C.
Right.
So go ahead.
I was going to say specifically for ABI stability.
Specifically for ABI stability, right? So I went through. We removed all the C++ elements, and I'm just starting to look at SQLite3 as another more significant module to port over. Ian?
Cool. So a while ago, I had started the NAN examples with a prototype of this API we're working on, and then Michael took over it. And then I started looking at level down, as Aranesh had suggested, as a good example of a native module that is a fairly chatty interface to the client. And so I just completed that yesterday, so it no longer has any V8 imports, which I can show later. And then next steps will be to investigate how this affects the performance of level down.
Okay, Samson.
Yep. So I was first working on how to kind of change the init method that we use. Initially, we use node modules macro, and then that takes in a function use VA type, right? So I create a new macro that takes in the NAN API, like an API type. Yeah. So and then right now I'm just building new tasks for our APIs. Yeah.
Okay, Ali.
So I've been making slow but steady progress on implementing dynamic FFI. So I have a proof of concept working that basically deals with integer types. And the next step for me are to actually find a module that I can start playing with, trying to implement it using FFI.
Is that like the changes you've had to make? Are they to Node or to V8 or?
They are to V8. The basic idea is the JIT compiler generates the bindings for you to be able to call a C function. So you give it a signature, and it generates the glue code to let you call that from JavaScript.
Okay. Sounds good. I see we have additional attendees. So Barrett and Patrick, do you want to add yourself to the? I see Patrick has nothing more to add. I guess Barrett, do you have anything to add to the roundtable? If you're speaking, you're on mute.
Oh, he's lurking as well, he says.
Okay, no problem. If you guys could go to the notes I just repeated them and just add yourself as attendees, that would be great. Okay, so moving on to the next action in the agenda, which were actions from last meeting. Let me see if I can find those. So I actually had an action to review the README to see if I can improve positioning versus the NAN working group, and I'll be honest, that's fallen off my radar, so I'm going to have to sort of loop back and add that back to my task list. So moving on to the next thing in the agenda, the update for the ABI Stable Module API. Our plan is to basically, show you a little bit about what the functions we've already defined look like, the NAN examples so that you can see what they look like before and after conversion, and then the the larger level down conversion, because there's more sort of interesting things there as well. So I think you figured out how to share your screen, right? So maybe if you start that and open up the repo, that's a good way to start.
Yeah, let me get the repo open first. Okay. Okay, can you all see that?
Yep.
Yes.
All right, so we've been working in a fork on my GitHub account in this branch API opaque prototype.
Right, and just as a reminder, that's something that maybe we should discuss at the end as well in terms of if that, we continue to work there or it makes sense to move somewhere else. We'll
Right.
start to the agenda.
Okay. And then the bulk of the API here is in this Node_JS API. All the names that we have here are kind of, they're not ideal names, or we haven't thought about the names in too much depth. And there's like a big header here saying that this is all proof of concept. All right. Well,
Is there a way you can make that bigger?
Is it too small?
I don't know about for anybody else. It could be a little bit bigger for me.
Is that better?
Yeah, I think that's good for me. Everybody else, that look okay?
Yep.
Cool. Let me just jump into the types real quick, this header here. So the idea behind this prototype API is to only use opaque pointer handles and not have any actual, as much as possible, any defined structs, so that API stability is easier. And I guess VM neutrality comes easier that way too. So we have just a bunch of types here, and they're all undefined structs that are type def to pointers. And this is how you do it in C to get opaque pointers that are type safe. So we've got a type here for a general environment that is passed around to all the APIs. Value type that represents a JavaScript value. So your objects, your primitives. A persistent to represent persistent handles to things you want to keep alive, which is analogous to the V8 persistent. And then handle scope and escapable handle scope are analogous again to the V8 handle scopes. Property name is a type for names that are used for properties. And in V8, they are just strings, but in other VMs, they might be special handles. And then a callback function info, which is similar to the V8 function callback info. It gives you all the data, or the information that's passed to your function when you're called from JavaScript.
I think the other thing to mention here is that we have discussed that for type safety, there's still work to be done on that front. So that set may expand when we get to looking at that particular aspect.
Yeah. Notably, this API has removed the C++ type safety of working with specific JavaScript values. So like if you're working with a function or an object, they're all just an API value type. And so we haven't thought much yet about how to address that, but we figure a C++ wrapper helper can help there. All right, are there any other questions before I go back? Nope? Okay. So the API here is kind of a just very flat, simple C API that mostly provides JavaScript operations. So it's similar to SpiderMonkey's old API before they added C++ stuff to it, and similar to the JSRT API from Chakra. But basically, you have your JavaScript primitives and operations. So this value type is the JavaScript types. It's undefined, null, Boolean, number, string, simple, object function, which corresponds to type of. And then we have, you can get those singletons, the undefined, null, false, true, the global object. We have things to create JavaScript objects, just the variety of them. And we expect that this is clearly not a full list of what would be needed, but this is what we've needed so far to do our conversions of the examples in the modules.
Yeah, and that's one thing that Samson is working on along with adding tests is, filling out the set of get and set values.
Right. Right. So that's what's here. Next is how how to convert JavaScript values into C types. So you're getting an int32 from a value or a bool from a value. And these are just kind of the dumb operations. They don't try to do any coercion or call script code. And then down here we have the actual coercions that can happen in JavaScript. So like toObject or toString may call script code. And they take a value and give you back a value. Working with objects, then you're working with properties in the prototype chain. So APIs to get the prototype object from an object, or get a property, or see if an object has a property. We have a set of APIs for elements, which are indexed properties, basically. So uint32 indexes. Arrays are kind of special. They're not a JavaScript type, but they are an exotic object that can be handled specially, and so it's nice to know if you're working with an array. So right now, all we've needed is to just see if something is an array and get its length. We've needed strict equals, so we have strict equals here. So we would have the other, I'm sure, the other JavaScript equality and comparison operators here as well in the full API. Working with functions, if you have a function object, you may want to set its name. That's a new ES6 feature, names for functions. And then, of course, you may want to call a function, so that's where reentrancy happens. That's where you would call back into script code. A new instance is calling a function with a new operator, so as a constructor. An API make callback is a wrapper for Node make callback. I haven't dug deep into that yet, but we set it up so that level down can use this instead of Node make callback, which has V8 types in the signature. This set of APIs here work with the function info callback, the function callback info data. So this can get you how many arguments there were and get fill a buffer with those arguments. Get the this or the holder, see if it was a constructor call, and then finally set the return value for when you return. Object wrap, and Michael can talk about this more in the examples, but we have some methods to do the object wrap, and in a kind of flat C API way. Notably, we've done it so that you don't have a class because we're not C++, so you can't inherit from object wrap. So if you want to have a handle back to this thing, you have to request a handle. So there's this parameter at the end here to get a handle back. Then we have lifespan APIs, so creating persistence, working with them, handle scopes, working with them. So this is another interesting thing where since we're a flat API, we have no C++, we don't have RAII classes to manage scopes. So all of these are wrapped in helpers currently. Well, we don't have persistent wrapped, but we should. Wrapped in C++ helpers that will just do the create and release or the open and close for you in a C++ scope automatically, so you don't get tripped up by this. We have an API here for throwing any value, which just corresponds to JavaScript throw. And then this here, this try catch, I just added yesterday, and it hasn't been deeply thought about, but is a wrapper so that you can put down a catch handler and then run some more code, and then run a catch handler with your code in it if you want. So this actually places a try catch in the VM on your call stack and wraps your C++ code or your C code with that try catch. And then finally we have a few APIs to wrap the node buffer functionality, which level down uses. These are just straight wrappers to eliminate the V8 types. So that's the API we have so far. That's the API that is exported and would be imported by your module. Are there any questions about that? I can't see the chat, so I don't know if anyone's talking in the chat.
I don't see anything over there.
Okay, cool.
Sorry, but Barrett did ask about promise support.
Sorry?
Barrett asked about promise support.
Promise support? We haven't run into promises yet, so we haven't considered that yet. Does Barrett have any particular concerns about promises? Like, is there anything that seems like it wouldn't work with this approach?
Or maybe the best question would be if you know, Barrett, if you know of a module that uses promises on the native side, that would be a good example for us to look at.
Yeah. Okay. So that's the thing we can consider soon. We should put that down somewhere.
Yep. All
right. So after that API, we've got some helpers, and a lot of this is influenced by Nan. So a lot of it is lifted from Nan and then re-implemented with this API instead of V8. So that's what you're seeing here. These are the macros, some helper macros from Nan. Then we have this namespace and API, which has the wrappers in it. So handle scope and escapable handle scope. And so these were written kind of to make conversion very easy, but then also provide that RAI safety. So this, and you'll see this when we look at level down, the conversion here kind of boils down to just changing nan to nappy in your namespace qualification.
Right. Now, I know we haven't discussed this, but I'm thinking those wouldn't be in that include file. They're likely a separate module or something like that people could use.
Right, yeah, they don't need to be part of this header file. They could be part of Node, or they could be a separate module.
Yeah, the only concern I have about being part of Node is then we're back to the C++ and ABI stability, right?
Well, no, so these are all written, so I have a note up here. These are all written so that they do not export anything. So they're all header inline. They only use the C API that we have above. So there's this warning here.
Right, okay, so the API, yeah, okay. So, right, it's all inlined, and then, so even if we change them, yep, okay, understood.
Right, and I can show later when we look at, I have a dump of the import symbols from level down when it's compiled for V8 before I made any changes, and when it's compiled for the nappy after I made all the conversion.
Okay, great. That's...
Nan has UTF-8 string, which level down used, so I implemented that. So again, these helpers are not comprehensive at all, so we would expect to fill this out significantly similar to Nan. This is similar to Nan callback and is a wrapper for Node callback. And then async worker. So Nan provides async worker, which level down uses. I was a bit worried about this at first, but it turns out it doesn't have a lot of code to it. It's just kind of a wrapper around UV APIs. And so it was pretty straightforward to implement the new N API. But that does mean that we still have libuv imports. And libuv is a C API, but I don't know how stable it is, and I don't know if that's something we also want to shield modules from, or if we want libuv to be stable as well. And you can see those imports here. Async QWorker uses UV QWork, UV default loop. And then down at the bottom, we have some things that we don't intend to include with the API, but these have proved very useful for the conversion process, at least so far. If we can make conversion more automatic, these might not be necessary, but they were helpful in keeping level down running while I converted it piecemeal. Well, that's the API. But any questions about that?
Ian, can you explain the GC differences and how you're handling the handles?
Sure. So that's a good question. So the different VMs have different garbage collectors. There's two groups. There's conservative garbage collectors and precise garbage collectors. So the conservative garbage collector just looks at memory, and anything that looks like a pointer, it considers a pointer, and if it's a pointer within its GC allocation region, it says that thing's alive. Whereas a precise GC knows where all of the roots are. So it doesn't look for pointers, it just knows where they are and then traces them to find the graph of objects. So abstracting those two things together takes some thought. After discussion with some people on the Jaka team and then discussion with Michael, it seemed like, at least for now, what makes sense is the all-encompassing thing is to work with handle scopes. Because in our thought experiments, the handle scope should work with some effort for SpiderMonkey. A conservative garbage collector doesn't really care, so it can be no ops. And then, of course, it works with V8 still.
We think that the concept of saying we're entering a scope where the references will be released when you exit that scope, it applies across them, and like Ian was saying, in some cases you may just not care at all, so you can make a no-op for when you enter and exit, but those are not common events, so even if you have to implement those calls, you're not having a great overhead. So it seems like the concept is applicable, and for ones, so far we don't think it's going to prevent any of the different types from being able to optimize or get good performance with that, having to handle a enter scope, exit scope, possibly just with it being nothing that you do when that happens.
Right.
Okay. Thanks.
Bro. Okay.
So Barrett has some more questions.
Sorry, can you say that again?
Barrett has some more questions on the chat.
Right, yeah. I guess he mentioned that he doesn't have a mic, so he's just typing it in. But I guess it's like something about being able to return a promise instead of callbacks. I guess it's if we could find a module, we'll have to look for a module that uses promises, because I think that will give us a concrete example of what we might want to look at. In terms of WebAssembly, I can't claim to be, well, I don't know enough about WebAssembly to talk about that. I don't know, Ian, or you know much about that?
A little bit. I haven't worked on it directly. I think so. WebAssembly, I don't even know if Node.js has a lot of plans to integrate it at all yet, but basically is a binary format for JavaScript kind of bytecode, which an engine can then use directly. So you can write your program or your code in some other language and then compile it down to this WebAssembly, and then the JavaScript VM can just kind of run it. But my understanding so far is that you call into the program and then it comes back to you. I don't know how integrated it is with JavaScript, and I'm not an expert there to talk about it.
Yeah, I know it was discussed in one of the CTC calls, and my understanding out of that is it's not a replacement for add-ons, but to be honest, I can't remember enough of the details to speak to why not. So that may be something else we can take a look at to do some more reading on.
Yeah, definitely. We should probably open an issue to track that.
Sure. Yeah, that's a good idea. Okay, so I think we're going to move on to the NaN examples.
All right. Do you want me to show that then?
Since you're already showing, maybe it just makes sense for you to continue.
Yeah. Okay.
So I think maybe if we just open up the the first hello world, the GitHub repo, and show the directory, start with.
So the Node add-on examples were set up to show how to write native modules against Node 10, Node 12, and NAN. And so we've added ABI, which includes the NAPI versions. So if we, well, let's first look at Node 12.
And just as a hint for people, you can click on the little arrow in Ian's box there, and it'll continue to show his screen regardless of who's talking.
Oh, it's switching back and forth.
It was, but until once I click that, it sticks. So.
Okay, good. So Node 12 example of this hello world. So the JS file I don't think has changed, but we require bindings, which then pulls in hello, this add-on, and then we console.log a call into this add-on. It has a method named hello, which gives
right,
back
and
the string world.
One of the key things to mention here is, yes, the JS file should basically be identical to the other versions. You know, our goal was to make the example as close as possible to the original and to run in the same way. And so the only places where changes were necessary were things like the C files and not in the JavaScript files.
Right. And then so this example in Node 12 looks like this. So you have your init function, which is hooked up to Node with Node module down here at the bottom. And then the init function adds a property to the exports object named hello with a function, which is this callback method up here. And then that just returns a new string from a C string world. Creates a UTF-8 JavaScript string, a JavaScript string from a UTF-8 C string, and returns that from this function. So that's pretty standard, straightforward stuff.
So that's the original version.
That's the original. And then if we go look at, we can look at NAN real quick to see what NAN looks like. So NAN kind of just removes the isolate and tries to simplify things back. So you have the NAN helpers like NAN new, and isolate is missing from this, but it's mostly the same. And then if we look at API, so we're including the JSVM API header here. Now this looks a little more verbose.
It's mostly the parameters are longer.
Right. So we have Node module API down here is the new macro that Samson added, which hooks up your init function using the new signature, which has no V8 types in it. So currently this is just like a third option for the init callback within the Node registration. And so, yeah, so you notice we now have this environment that's passed around to everything. And the idea there is, like the isolate, I guess we want to have, all VMs have like some notion of their runtime environment. And so this is to pass it around. So you have, if you have separate runtimes, the API has it built in.
Yeah, and whatever implementation, you know, it may vary between the implementations, but it really doesn't matter to the modules. They just need to, you know, they get it passed when they're called, and they need to pass it through to the other places. Right.
And this is something that obviously we can hide through helpers if modules don't need this. If some modules don't need it and they want to be simpler, like with NAN, you don't have the isolate hanging around because it always gets the current isolate. Otherwise, it's pretty much the same thing. We just now have the NAPI calls. So back in init, we're setting a property on the exports object, which is a nappy value. Its property name is hello, so we create a property name from the string hello, and then we create a function object from method. And method is up here. It takes that nappy func callback info, and then you can set the return value on that thing, which we create a string as the value from the string world. So it's pretty good, and so now it has no V8 imports. So there are any questions?
So just a quick note, I think I missed part of the discussion. There was talk about getting isolate get current. The NAND does isolate get current, and whether something might be done here to match that. Note that I think V8 has plans to deprecate isolate get current eventually, so I would advise not relying on it.
Well, I think the comment is that, you know, we've got at this end this part of the environment. There's some wrapper that we can get that.
I see, but Ali, you're saying a V8 is thinking that it is no good to provide this kind of help of getting the current one, and you should really design your program to always pass it around.
That's my understanding from the V8.
Okay. Yeah, okay, that's interesting. So it's basically, yeah, just make sure people pass it through. Okay.
That's kind of like, I guess if we're designing this thing now up front, don't give them the ability to take it easy.
Right.
And then paint themselves into a corner. Okay. That's a good point. All right, should we look at another one?
Yeah, I'd say like maybe jump to one that shows functions being called.
So callbacks, is that?
Yeah, let's take a quick look at that one.
So what does this do? Yeah, so this passes a function to add-on, which then calls it. All right, so now in this case, in the init module, we're working with the module itself, and we replace the exports property with a different object. In this case, we replace it with a function. You can see that down in init. And so what Samson has done, what we decided was just to have both exports and module passed all the time. There's no reason to really have it separate. Then this callback here, we decide that this thing is only going to have one argument that it cares about, and then we get that. This API here, if an argument wasn't provided, we'll just put undefined in the slot in that args buffer. So it's always safe to call it with any number. It'll just fill it with undefined at the end.
There also is a method to get the length. So if we wanted to, we could say, tell me how many arguments there are, define args, and then just get that number.
Right.
It's just that this example, I think we stuck to what the example was doing, adding extra stuff. So.
Yeah, I've seen a lot of examples, and I think going through level down, a lot of it is just like, I assume that I'm going to have 2 arguments, or I'm going to have 3 arguments, and then I'll figure out what they mean.
Yeah.
So that's a pretty common case. The callback here is the first argument. So this is not the first argument in this buffer. This is a special thing you have to request separately. And then we create an argv buffer here to pass to the function to call it. We put in it the string hello world as the only element. And then we call function passing the global object as the this, and giving it, so this is the function object that we're calling, and then we're saying we're going to have 1 argument passed, and this is the buffer of arguments. So pretty straightforward stuff.
That callback was that was the function passed from the JavaScript side of things.
Right, and in this case we are ignoring the return value, but it would give you back a nappy value that is the returned value. Which actually reminds me, something to note here, we haven't thought about error handling at all yet. Being a C API probably will have error codes that are returned by every API. But it's a detail we haven't dug into yet. Cool. Any questions about that?
So then maybe jumping to, I don't know if there's other one interesting, or like jumping to one of the object wrap ones.
Probably object wrap.
Okay.
Do you know, so you did this work, do you know which one would be good to?
I can't remember at this point. Let's just pick the first one.
Okay.
Like the other ones are all just sort of derivatives of things, so.
Yeah. Do you want to look at the original version first?
Yeah, sure. Let's open up that one. And the interesting, well, let's take a look at the addon.cc first, but not really though. Yeah, okay, the JavaScript one is a good idea too. So.
Right. So.
We basically create, a new instance of the object with a particular value, and then we call methods on that object, and print out the value. So in this case, we're starting with 10, and we would expect, 11, 12, 13. You then go to the addon.cc. There's not as much interesting here because really the logic is out in the other file we'll look at next. So really it just, yeah. So if we look at my object, so this basically is an object, and in the case of the existing APIs, you extend object wrap to get the object wrap functionality. You provide, an initializer, and then you have like a constructor destructor, and then the methods that you want to implement, and then they do store the constructor in the static so that it can be used across instances when you want to be able to create new instances of the object. And then the double value is just the value that's going to be, when we created the instance in the JavaScript, we gave it 10, so that's where we store the current value. Over to the CC. So here, I guess, the initializer basically sets up and creates a constructor. So that's what we're starting to do here. It uses the function templates from V8 to set up that template. Sets the method, which is the +1 method. It then creates a persistent, which is our constructor, and the reset is basically, setting the, when I say TPL get function, it's getting a function from the function template, and it stores that in the persistence so that we can use it irrespective of the instances. Sorry, so in the new, it basically, depending on how this was called, so if it was called from a new, it knows that, it can basically create things in a particular way, or if it was invoked as a my object, then it basically first turns it into a constructor call so that you end up with the same thing. If we look at the case where it says is constructor call, it basically says, okay, let's get our value. We're going to create a new instance of the objects. This is a regular C++ new on my object. Passing in that value. It then calls object wrap, passing a pointer to this particular C++ object, and then it returns this value, to return the object. So we're being called, this new ends up being called when you say new from the JavaScript side. So you have an object, the wrap, by saying, wrap on my own object with this, args.this says, okay, I'm going to add the pointer to my C++ object to the JavaScript object. And then it just returns itself as, the JavaScript object as the return from the new call. The rest of the functions are really just, things we would be used to in terms of, they're getting values, +1, multiply, and those are, done just like we would have done for any other function. It's just that we happen to define them as C++ methods, and then those C++ methods are bound as the actual method to be called when you call when you call, say, +1 on the JavaScript side, it calls this method normally, just like any other method, but it figures out that that the object that I'm calling it on has a pointer to the C++ object buried in it. It uses unwrap to pull that out, and then it calls that method on the particular instance of the object, and then just returns the value. So basically, you see the common pattern of basically unwrap to get the object, do the data on the object that needs to get, if we're looking at the +1, it says, unwrap to get the C++ object, add 1 to its value, and then just return back the value itself in that case.
Cool.
So I think, now if we flip over to the nappy versions.
Whoops, too far. So the JS should be the same.
It's actually should be exactly the same. Now this is the point that it's actually, if we looked at the NAN version, this would be exactly the same as the NAN version. It seems like the 10 and 12 versions have less in the test. So that's why, we have the multiply, but it is exact. We can look at the NAN one. It's exactly the same as the NAN one. It's just that it had more than some of the other versions.
Right.
In terms of the addon.cc, you can see that's the same. So really, the interesting part is again, in my object, again, it looks very similar though here. We don't extend from async wrap, of course, because we're not exporting anything from the C++ side. But otherwise, it's pretty much exactly the same, except for the persistent, which is a nappy persistent instead of the V8 type. And of course, all the conversions to the nappy types as opposed to the other types. The one interesting thing there I would say is that we've added this destructor so that you can, because it's not C++, we still want to have a way that you can say, okay, now it's time for this to go away. And you'll see that, if we wrap it in C++, we just need to make sure that we call the destructor that will then, call the C function that does the equivalent of a destroy. So in this case, we start out, the persistent is again, just a different type. We have our constructor destructors. We do have this new destructor, which I've added, that actually you'll see says, call the destructor on my object itself. And, I just defined that so that we can pass that into the functions when we wrap things. So we go down through the init. It's a little bit more verbose in this case in that we haven't added helpers to help you set functions on, functions on an object. I think, when we get to the end, we'll probably have something which is add a function as opposed to going through these steps where it says, create the function, add it as a property to the object.
Yeah, it's good to point out here that this, the way it's done right now, doesn't take benefit from the V8 function template optimization, because when we're adding the properties at this point, we already have a function object. But if we had helpers to do this, we can do it in a way where we can take advantage of the function template.
It does use function templates behind the scenes, but it doesn't use. Yes, we can instead of the create function, we can have a create function that then takes additional things. And similarly, I think a create object that can take some multiple things and let an optimize.
Right. Okay. Take that blueprint and then that's one to go.
Yep. So these are basically just going through and saying, okay, let's add the functions to the JavaScript object. We create the persistent, in the new way, and then we're setting the property, similar to the other way. We're just saying, okay, we do it in the nappy way. So moving on to the new, this is where we can say it's a little, it's again, we're using the nappy API to get the parameters. Once we have that, we still create an instance of our own object, and we call nappy wrap. And in this case, we're still passing in a pointer to my object, and we pass in this destructor, which lets us basically say, here's what should be called when we want to destroy this particular instance. And that's important because I believe that when the JavaScript object goes away, you want to be able to delete the C++ object as well. And that's how we get this through the C API. You're basically saying when the JavaScript object is no longer referenced, here's the method you can call that will destroy the C++ object. And then the null pointer, if I remember correctly.
So that was added when we added the, if you want to get a handle back to this thing for the C side. So if you want to handle back to the JavaScript object that is wrapping your C object, you can get it through this parameter. It's optional.
Isn't that the same as JSDiff?
As what?
As JSDiff? Anyway, maybe we'll talk about that because, I think it's like you're basically saying wrap.
You might be right.
Or as obj actually, because we're passing in the object to wrap the C++ thing into anyway. So.
Right.
Anyway, okay, so we may get rid of that if that's the same thing. But basically, we wrap in. You've got to wait for it to be destructed, even though it's we're only using the C API. And then we set the return value as, this object. So again, then when we go into the functions themselves, so like get value +1, it's a similar, we just call the unwrap, which basically gives us back a pointer to our C++ object. We can operate on it just like we did in the other case, so that code is basically the same. And then, we just set the return value. So it looks pretty much the same as you had with wrap and unwrap, except for when there's that extra destructor. But the code that you write, other than the unwrap and wrap, is I think going to be the same as before. The other things in there are basically just the other methods, so they're just other examples of the same thing. So I'm not sure there's anything else different or interesting. Does anybody have questions on the object wrap front? No, I think we should probably move on then, because we're already at the end of the time. So let's. Can everybody keep on going for a little bit?
Yep.
Yeah.
Okay, so let's keep going. But yeah, maybe if you can flip over to the level down stuff.
Yeah. So let me start with the imports. So I finished the conversion of level down to this API yesterday. And so an interesting thing to do is dump the symbol list of imports and see, verify that it's not linking to V8 directly anymore. So this, let me go down because it's alphabetical. So the V8 version, so this is before any of my changes to level down. The imports here, and this is on Windows with the MSVC compiler. So the delay load imports here, you can see that we've got the V8 C++ name mangled imports. And so this is all using the V8 API. And then libuv down at the bottom too. And node module register is the symbol for, is the function for registering your module. And then if we go look up at after my changes, so that the same Windows stuff. But now we see there's no V8 C++ imports here. It's all the flat C API and libuv. So that's pretty cool.
That's cool.
So the idea would be then, like, this API stays stable, and your module doesn't necessarily have to ever be recompiled, as long as it stays stable.
Yeah, and one of our things in our goals is to actually backport this to an older version, just to validate and show that. But this is a good way as well to show that that should work, right?
Right. Okay, this is a diff of level down from before my changes to the end of my changes. And we can just look at some of the interesting parts here. So the nappy helpers that I talked about earlier, you can see now conversion is kind of very simple. In a lot of cases, it's just converting the nan to nappy. So this is a class async worker, so this is level down's async worker, which is inheriting from, used to inherit from nan async worker, and now it inherits from nappy async worker. There's a little bit more change, so like we can't use nan callback, so we have just a JavaScript value as the callback. This is a refactoring that probably doesn't need to be there, but so pretty straightforward. Nan persistents are replaced with nappy persistent. This is interesting to note. So nappy persistent is just that opaque pointer handle. So this isn't actually releasing this thing, and we don't currently have like a module D in it. So technically, when the module is removed and Node shuts down, this should be released. But we can solve that with C++ helper. This is the, as Michael was just mentioning, when you have object wrap. So this batch thing is an object wrap, so it has to have a destructor. In it is the same sort of deal. So this is where we just set up the constructor with a bunch of methods on it, and it's the same thing we just looked at in the object wrap example. Same sort of deal here. The env, so the nappy environment is now passed around everywhere. So a lot of level down code APIs or interfaces had to be augmented with the environment. So that's kind of a little bit of an annoying conversion detail, but I don't really think there's going to be a way to get around that. Especially if V8 is going to deprecate isolates. That's something that people should, or get current isolate. Sorry. That's probably
it may be forced through that anyway, right?
Right. So this batch class is kind of the same as the object wrap example. It's all just a bunch of methods that are hooked up to an object wrap. Here's the header file where you can see we're no longer inheriting from object wrap because we now use nappy wrap and unwrap. And here Nan had a helper for defining the signature of callbacks, and so since we have a different signature, we have a macro to help you with that too. And so that forces the names of the environment to env and the callback info to info, I think, which matches, the info matches the name that the nan macro uses. I want to look at something more interesting. So I think if we look at level down at H, there are some macros in here that level down uses as helpers to extract a bunch of stuff from the callback info. Let me look at something I remember. So load method setup common. So the methods that use this macro are object wrap callbacks, and they expect 2 arguments, an object and a callback, or an options object and a callback. And these 2 parameters are indicating the position in the arguments where they are expected to be. And so this macro here, maybe I should do, oh, so this macro, sorry, would set up a bunch of local variables that then the method implementation would use, and they're all set up nicely in the same way. So just kind of convenience that level down had for unifying the way they do their callbacks. And so it's interesting just to see how, so now we have to get the arguments, which we use here, instead of just pulling them off of the callback info. And we have to get this because this is used. But then, just as it did before with the options object and the callback, we have the same, but they're nappy values now, and we populate them the same way.
So it uses this and not holder, right?
It did use holder in a few places.
Okay. Because I mean, I know in the case of the examples, I think I looked at it and said, I think you could just use this instead of holder. And that's what I ended up doing. So I'm just curious, like, if you looked at them and said, okay, well, we don't really need holder, we could use this, or...
So it's an interesting, holder is an interesting concept. It's something that V8, so I looked into it a bit, and V8 has it, and I don't think the other VMs have it, but it seems like something the other VMs could emulate. The idea is you might call an object wrap or like a callback on some object. So in JavaScript you say foo.bar, and bar is your callback function that's written in C++. And foo is some object. And then the C++ function could assume that this then is the special object it knows and will cast it to the type it wants and then pull off private data. But because of the way JavaScript semantics work, you can pass any object to that method because the method is really just a function and this is just a way, it's just a formality. So if you pass the wrong object, you'd get the wrong pointer and you would cast it and then blow up, and it wouldn't be good. So holder is a concept where it will look at the prototype chain of the object that was passed for this and search for an object that was the object that has the method that is being called, and then give that back. So that thing is guaranteed to have the data because it's tied to the function. So it was tied to the function when the function was created. So anybody who relies on that...
It's something we do think other VMs could emulate is the sort of key.
Yeah. I don't know if it's a good practice, but I don't know another way to solve it. So it might just be the best solution, and it might be something that other VMs would have to emulate.
I guess the other option would be, if you're writing safe add-ons, you just, you got to make sure that you don't call them with just some arbitrary object, right?
But the module author can't guarantee that for the module client, like the user.
Right.
And this is a concept that V8 has for its own built-ins and things. So it's not specific to Node.
Right.
Like it's a general problem. For example, in Chakra, our built-ins do the same sort of thing where we cast this object to our internal type.
Right.
And then pull private data off of it. And the ECMAScript spec itself also does the same thing. In its definitions for the built-in APIs, they will say, this object, if it is this type, then I'm going to pull these internal fields off, which are not accessible to JavaScript.
Right.
And the way that the ECMAScript spec and Chakra do it is with a tag. So we create the objects and we own the way the objects are laid out, so we can put tags on them. And so we just have a field that is an enum, basically, and we can say, is this object this built-in type, and we can pull data off of it. But Node can't do that, really. That's an implementation detail of the VM, and exposing that in some way, that's not possible. So the holder solution might be the best.
Right, okay. So it's like an optimized way to help. Yeah, okay.
Yeah. I don't know if there's really much more interesting in here other than that, like, it's all kind of the same. Nappy helpers are easy to convert. A lot of the types just become nappy value. So if we look for nappy value, actually what we should look for is V8 string say. Not that one.
So certainly we could use the helper approach to do more for man, like the new and stuff like that. Sounds like that'd be a pretty straightforward one.
Yeah. So we have a lot of cases where the code used to have a strong type, for the handle to a JavaScript object. So it knew this is a string and it can only be a string. And now we have nappy value, which can be anything, and you have to query what it is before you assume anything. V8 has that object concept, like that's V8 value, but this conversion has removed a lot of the safe typing. Like when you create a thing, you know what it is, and when you pass it around, you can maintain that type safety to other functions you pass it to. Or you can have signatures that require a V8 string. But now it's just nappy value, so you have to push down your tests for what these things are into the parts of the code that actually use them. So it might be useful to conjure up a way to have C++ template helper that can provide that same type safety.
Right. Yep.
Yeah, and let me just quickly look at my notes. I don't think I had anything else. Where did my notes go? Yeah, those are the main points. The conversion is pretty straightforward. I'm sure we could automate a lot of it. This is one data point, so this is just level down, so we'll have to learn more from doing other modules.
Yep.
Michael's
I guess the next step is, the good thing is this gives us the basis now to start doing some performance analysis to say, okay, can we see a noticeable difference between the two versions that we have?
Right, yeah. So now that we have one complete, we can go now run its benchmarks. It's nice that level down has a small suite of benchmarks. And also its tests, and run them with release builds and see how the opaque handle API has impacted performance, if at all. So the idea here is, with using the V8 types directly, the C++ compiler can look at how they're laid out and optimize a lot of things and inline things, do heavy optimization. And with the opaque pointer handle API, it can't do any of that because it doesn't know what things are. And then the thing we want to see is how much of that is actually an issue for native modules. Like, do native modules make such heavy use of V8 types that this will actually be an impact? Or is it so chatty that going back and forth through these, not having inlining and having to go back and forth between the native module and the node code, is that going to be a performance hit? So that will be the next thing that I start to look at.
So I think that's what we wanted to present on this front. Does anybody on the call have questions, or before we move on to the other agenda items?
No, this is great.
Okay, so let's pull up the agenda. So the next thing we had was, okay, sorry, I'm scrolling down. Sorry, where did I write that down? Milestone planning. So we did open an issue, so I'll go find that issue and paste it in here to have some of the things that we know we still need to do. Okay, so just give me 1 sec to find that, and I'll paste it in the chat.
I guess I don't need to present more, do I?
No, I think the rest of the stuff people can probably open up the files themselves directly. So there's the link to the it's API issue number 23 in the API working group thing. So, this is where we've, have our current view of the object thing, of the things that we need to look at, and to, work through to get to the end point where we basically say we have a feasibility analysis complete. Because that's the goal of this, is to, build this out far enough to say, yeah, we believe that, performance-wise, there's no issues. We've implemented, what we've seen needed by a bunch of functions. We validated that it's really ABI stable and that we can do things like porting back to 0.10 and it still works without having to change your modules. And I guess we still have a few, we've worked through some things so far here. So, we have our first examples running, we have all the NAN examples running, we have the module lifecycle methods in place. You'll notice that a bunch of what's left is sort of like filling out the various versions of the APIs. We have the create get for what we needed so far, but not the full set. So filling that out. Things like, we've done some of the exception error handling, coercion functions, but there's probably, still a good number of those to fill out. Level down running, I guess we can check off here. As, we have that running great, just as of yesterday. We want to do the same for several other modules. We want to do the performance analysis. A test suite. So one of the things I do think we want to do is to expand the native module API test suite. So we've discovered there was an existing set of add-on tests under the Node test directory, and so we think this is an opportunity to greatly expand that to do more not performance testing, but functional testing across different use cases. Create string in JavaScript, validate and get the right thing in C, create it in C, validate and get the right thing on JavaScript, just so that we know that this new API is still doing the right thing. So that's one of the key things we want to do is fill out that test suite. And so robust error handling, filling it out. So there's still a lot of work to do. I think what we've got is really good so far. We can show those NAN examples running. Ian's completed that conversion of what's an actual some different modules, so that's great that we haven't found anything that's really been a showstopper yet. We still, sorry, go ahead.
There are some other items on the list which I believe was done as well, right? The coercion functions and.
Well, I think we've done some of them. It's whether we've done them all, right?
Oh, okay.
Right. So those are just sort of the checkboxes to say, okay, are we now convinced all of the functions we need in this place are complete or not?
Mm.
So I don't know. Ian might be able to comment on some of those. Like, I know you filled in the buffer ones. Did you do all of them? If so, we can probably check that off.
Yeah, I would say we're not ready to check anything off yet because I haven't confirmed that that's all we'll need. And I think that requires doing a lot more of the other modules first and doing a lot more analysis of what's out there and what.
Yeah, sort of understanding how they're used and stuff like that.
So the question I would have is that if we are able to check all the boxes here, what would that mean? Would that mean that the code we will have at the end of the completion of all the checkboxes here will be ready to be used by the community, or we'll say that we have a really high confidence that this is going to work really well in the community?
Yeah, I think at that point, that's where we go back and say, we've shown this worked, we've shown the performance is acceptable, let's get the okay to actually integrate it as part of the API.
Okay.
Right, so that would be a point where we're saying this is a very viable proof of concept. Let's turn it into a real thing.
Yeah, we hopefully have all the data necessary to answer people's questions and convince people to say, yeah, okay, let's do it for real. And hopefully most of it is reusable, right? Like,
yeah.
We may have arguments over names, we may have arguments over, well, you need some more C++ wrappers, but I still expect that most of what we've got will be reused.
So would that be, once we get all the checkboxes complete, at that point we will submit a PR to Node?
Well, we have the EPS, so actually, I think one of our things we should do soon is to update our EPS to reflect the changes that we've made to the API. So we tried to, before having gotten started, to write out what the API might look like. I think we have a much better picture, so we should update that document.
Uh-huh.
And we should do that as we go along, so that hopefully we'll get some review, as we do that. I think once we're at the end of this, the first step is to say, we get approval for the EPS effectively, which is the node enhancement proposal, saying this is something we believe we're going to add in.
Yeah.
Once we have that, then it's like, okay, yeah, let's start submitting PRs to start pulling various pieces of it in. I wouldn't necessarily think it needs to be one big PR. We could start to pull in, smaller pieces that don't cause you to break anything, because we've done this in a way that existing add-on modules still work. You can still use the old existing way of linking directly to V8 and all that. So we could start to bring in pieces that don't affect anything else, but let us, because I think one big PR, that's always hard for people to get their heads around, right?
Yeah.
So I see it more as a stream of smaller PRs and say, okay, well, like we can add in the part that defines the module ABI init function, right? People can look at that, understand what it is, see if they agree with the name or whatever, then get that in.
Okay.
And then sort of do it piecemeal like that. Look at the logical pieces we can do, and we'll see.
And what's the estimation of time we are thinking about today, like based on how far we have been able to get to?
Yeah, off the very top of my head, and I'll let Ian correct me if I'm wrong, but like, I can't see us getting through all this before the end of the year.
Yeah.
And that that assumes we can continue to spend a fair amount of time on it.
Yeah, I feel the same.
Yeah.
So I'd like to be a bit more, to say we're going to get these different pieces done by a certain time, but it is a challenge. So like, I think that that gives me our high level, like, it's not next month we're going to be done, or even 3 months from now.
Right.
I think as we move forward, we'll get a clearer and clearer picture. The second module goes twice as fast as the first. I think we also wanted to get some feedback from people. So I'm hoping, we'll get some from, people having watched this or having attended here to say, yeah, we think that's looking like it's going along the right path or not. Because that will, if we get the thumbs up, I think that's also, has a big effect as to when we might be finished or not, right?
Yeah, that's a huge validation on the board.
So I think that's the other thing, if we've recorded this, if there's certain people, I think we'll try and see if we can now, send it to the people who we'd like to get some comments on, and try and push it on that front too.
Yeah, it would be good to solicit feedback from folks in the foundation, and then maybe also try to get buy-off on like continuing to invest here. Like, if anyone has any concerns that maybe this is going the wrong direction or something, that should definitely start to be raised now.
Yeah, maybe what we need to do is update the EPS so people can read about it, point to the recording for this so that you can go and watch about it, and try and push more feedback on the EPS to say, okay, this is getting more concrete. Can you give us the yay or nay in terms of the and that one, I guess we can. If we need to, we're not getting any input or whatever, we could, tag as a CTC item for discussion there to try and encourage people as well.
Yeah.
Cool.
Very cool.
Okay, I guess the next thing we had on the agenda was, so far we've been working in Ian's branch, and that's fine. There's sort of 3 of us contributing to that. It hasn't been an issue. It's nice in that doing it as a branch on an actual Node.js thing. We've got the commit history. The question is it appropriate to continue in Ian's branch, or should we be looking for somewhere else? Like, should we actually be doing this in a branch on the main Node.js repo, or not? I don't think that we have any strong feelings, like Ian, myself, or Samson, so we're just looking for input from the community in terms of, you think it should be somewhere else, or should we just keep on going with what we're doing?
Right, and I think that's kind of a question of, do we want to put it in Node.js so that it is now more publicly visible and obvious?
Yeah, so my 2 cents would be to linking back to the previous point of soliciting feedback, is that if we bring it to the main Node.js repo, we will improve visibility and hopefully getting more people looking at it and providing feedback.
Yeah, so maybe yeah, so maybe we should open an issue that basically is to start the discussion specifically on that one topic, saying, we made some solid progress on this. We've been working over here. Like, I think it's time to definitely point people at the repo so they can go look. We wanted to get it into a state where it was reasonable, which I think it is now. And then we can have that, use that same conversation to say, and is this still the right place to keep doing this? Here's some options. So I'll maybe take the action to open up an issue on the main node repo to do that.
Yeah, that sounds good. Probably we should tie that in with updating the EPS, because I bet discussion between the two is going to overlap a lot.
Yes. Yeah, I know exactly. Yeah. So I think So maybe we can talk next time we get together on Tuesday, like how we break up updating the EPS work.
Sounds good.
Because a main thing we should definitely do. And you're right. Yeah. Then open the issue, say, hey, look, we updated the EPS, we've made the solid work. Here's where it is, and
right.
Go from that. Okay.
Sounds like a plan.
Okay, so we are over the time. Anything, and that's our agenda. So anything else that people have that they want to talk about before we call it for today?
Oh, I was just about to ask if Ali wanted to talk about FFI, but he just dropped out. Okay.
Yeah. So I think we'll say that that's it for today. I'll type up the meetings and put them out for create a PR for review, and I'll add in some of the actions that we've identified in terms of the next steps.
Great. Thanks, Michael.
Okay.
Thanks, everyone.
Great. Thanks. Talk to you all later.
Bye.
Bye-bye.
Bye.